We're going to be looking at relation state. Previously in the playlist linked below the like button, we've gone over other relation model such as relation schema and domain as well. Relation schema is important because in order to have a state, one must have a schema. The lowercase r, where we have here, is going to be the state. So a relation or relation state, which is what we're looking at now, of the schema state, which is this, is denoted by little r, capital R. The relation is a set of n tuples, so we have just a long set of tuples, and we're going to have our r equal to tuple 1, tuple 2, and then so on and so forth, however many tuples we have. And we see with our relationship state, this is kind of like our attributes. And this is important because inside of each of these tuples, where each n-type tuple t is an ordered list of values. T is equal to like v1, v2, and so on and so forth. Each value, vi, 1 is equal to or less than or equal to I, this is less than or equal to n, is an element of domain a subscript I, and this a subscript I is going to be like this a1, a2, an, and so on and so forth. Or it's a special null value. Null means unknown or not applied to this tuple. So we have the retained name, we have the attributes, and remember the attributes are on top, and then we have our tuples, which is this table right here, where we have each of these rows. So we can see that we don't have any duplicates, that's going to be important. We have some nulls, that means it's not applied. That's really it for this table, just kind of showing the attributes and how the tuples are laid out. Each row right here at the beginning is our t, and then every single value in here, every value is going to be the v. So we have our r's and then our uppercase r, which means we have our relation schema or relation state, and then we have the subset of or equal to the domain a1 times the domain of a2 times so on and so forth until we hit the domain of our an. Now tuples are again unordered in a relation, so how the order is here, we could always move them around, that doesn't matter. A relation cannot have duplicate tuples, so we cannot have more than one inside of here. Next we have a denotion of cardinality. So we can denote cardinality, which is the number of values of domain D by a absolute value of our D. The maximum number of tuples in our RR is domain A1 with the subset times domain A2, and so on and so forth being applied together. We have an example here, so let's say we have a chart like this where we have our color and we have digits. We have our domain A1, and we have 3 different things inside of here, and then we have, or not our domain, we have our like tuple domains inside of here. So it's a tuple for each row, but they are our domains, yes. So we have our domain A1 times our domain A2, so we have like 3 times 2, and that's going to give us a total of 6. That's going to be our overview. It's pretty long for a relation state. It's longer than the notes we had for a relation schema and even our domain. That's going to be our relation model. We lastly have an attribute value to go over, and then we're going to move on to constraints, but that will be in the next video in the playlist linked below the like button.